Okay, here's the third example of a combined gas law problem, and in this case we're looking for the pressure at the end. So here you get a teddy bear balloon for your birthday and you love it. You want to keep it forever. And so what you always do with things that you want to keep forever, you put them in the freezer. Right? Freezes them, keeps them fresh, like the frozen vegetables and chicken you have now during the coronavirus quarantine. And it's a rainy, stormy day. That usually is associated with low pressure. And the atmospheric pressure normally is like 760 millimeters of mercury, and on this day it was 670. So that is pretty low. Anyways, the balloon begins with a volume of 5.7 liters. That's volume 1, 5.7 liters. Can you see that? Yeah. Pressure 1 was 670 millimeters of mercury. So that is a low pressure day. Temperature is pretty warm. The temperature one is 24.0 degrees Celsius. So that's a warm day, but it's a warm, stormy, rainy day. And now you put it in the freezer, and in a few weeks you decide to check on it, and now it's shrunk. So its volume is now only 4.5 liters, and the temperature in your freezer is negative 19 degrees Celsius. It's a little colder than 0 Fahrenheit there, so your freezer's maybe a little on the chilly side. Now, what is the pressure on that new day is the question we're trying to find, the value we're trying to find. Now, as we've done before in all these gas laws, the temperatures have to be in Kelvin. The volumes have to be in the same unit. The pressures have to be in the same unit. But the temperatures must be in Kelvin. So, and even that's a misnomer. They just have to be in a unit that the lowest temperature is 0. And Kelvin's what we use for that. So we're going to convert this to Kelvin. Keep breaking my pencil. So we do that by adding 273. It's like 273.15, but we're just going to add the 273. So that gives us 297 Kelvin, right? Did I do that right? I did. And this one, we add the 273 to that. That's a negative 19 plus 273. So that's minus about a 20, which is 253, and then add one, 254. So it's at 254 Kelvin. All right. Combined gas law is P1 times V1 over T1. Those values are always constant. I mean, no, that combination in that orientation is constant, so it will equal P2 times V2 over T2 at any other time and place. All right, what am I looking for? I'm looking for P2. Well, there it is. So I got to get it all by itself and on top. It's on top. That's nice, but it's got a volume and a temperature there. So let's move that volume over here. Divide both sides by volume 2. Boom, boom. Volume 2, volume 2. Multiply both sides by temperature 2. And we've got it. Temperature 2, pressure 1, volume 1. Divided by volume 2, temperature 1 is going to equal pressure 2. And now we plug those in. I'll do that over here. So temperature 2 is the 254. 254. Pressure 1 is the 670. Volume 1 is 5.7. Got to divide those by volume 2, the 4.5, and temperature 1, the 297. 297. Putting that in brackets, these have to be multiplied out first before you divide in there. Okay, plug it in your calculator correctly. So here we go. On. Clear that stuff out. 254 times 670 times 5.7 divided by the quantity. Got to put these in parentheses. 4.5 times 297. That's the dog. Boom. Enter. 700. That says, whoop, I made a mistake. That's 254. I put 245. Let's redo that. All right. I'm going to pull that down. Go over here and fix that. 54. Make sure I made no other mistakes. Looks good now. Boom. 725. That's better. Pressure 2 is 725.8. So 726 millimeters of mercury. Still not a very high pressure day. We would consider that low pressure compared to the standard pressure of about 760 millimeters of mercury. All right, there you go. That's the last one. Hope that helped.